So in this question, we are going to look at a body of mass 1 kg. So my M is 1 kilogram. It's tied to a string and rotates on a horizontal frictionless table, right? So sort of rotating on a horizontal frictionless table. This is M, and it is going to rotate like this, and there is no friction. Okay. The length of the string is 40 centimeter. So my radius of this circle is 40 centimeters, or it is simply 0.4 meters. The speed of the revolution is 2 meter per second. So V is given. So V is given to be 2 meter per second. So R and V is given, and we have to calculate the tension in the string. So as we know, if it is rotating in a circular motion, it has a centripetal acceleration. So A centripetal is equal to V square by R, and the tension here is acting as a centripetal force. So F Cp, which is tension in this case, will be equal to mass into centripetal acceleration. So now we can calculate the tension very easily. The mass is 1 kg, and that's going to be V square by R. So this is V is 2 into 2, 4, and R is 0.4. So that will cut, and basically we'll get 10 newtons. Okay. So answer for the part A is going to be 10 newtons. Now let's look at part B. The string breaks when the tension exceeds 20 newtons. So my tension maximum, which we can provide while keeping the rotation, is going to be 20 newtons. Determine the largest speed at which the mass can rotate. Okay. So now the F Cp max is going to be 20, and that is going to be equal to mass into V square by R. Okay. Mass is given to be 1, so it is going to be 1 into V square by R. R we now know is given to be 0.4 meters, right? R is 0.4 meters. So using that, we can now calculate the V max. So that is going to be 20R is equal to V square. It's going to be 20 into R is 0.4 V square. So with that, we can calculate the value of V square, which is 20 multiplied by 0.4, and that's going to be 8. So my V is going to be square root of 8 meter per second. Okay, that will be 2 root 2, right? 2 root 2 meter per second. So that's our part B. Now we're looking at the part 3. Now the concept of breaking tension is going to come. So the breaking tension of the string is 20 newtons, right? So my Tmax again is given to be 20 newtons. But you want the mass to rotate at 4 meter per second. As we know here, it is less than 4 meter per second. But if you want it to rotate like a 4 meter per second, right? My V now is 4 meter per second. Determine the shortest length of the string that could be used, right? So we have to find R, for which we can rotate the string at, right? So my F centripetal, which is T max, is going to be 20 newtons, and that will be equal to M V square by R. V is now 4 meter per second. We have to find the R. Okay. So we take the R on that side. So R is going to be R minimum, which is M V square by 20. M is 1 kilogram, and V is given 4. So it's going to be 4 into 4, and that will be divided by 20. So this will 5, and 4 by 5, which is going to be 0.8 meters. So when we are going to rotate it with a larger string, 0.8 meters, we will be able to rotate with a higher velocity, which is required, which is 4 newtons. So the answer for part C is going to be 0.8 meters.